Hello eye tracking community. My name is Michael and in this video we will talk about sequence analysis and how we can use artificial intelligence to search patterns in eye movements. In the previous video we have talked how we can use visualizations to analyze eye movements and to find patterns in the eye movements. In this video we will additionally use automatic components. Here on the screen you can see the end of the last episode. We've used a bar graph, a scarf plot visualization to show the transitions over the areas of interest. So how the attention moved from one area of interest to the other, indicated by the different colors. The task of this experiment or in this experiment was the following. We've shown this bar graph to the participant and asked them, please state whether there are two bars having the same value and please state or give the labels of these two bars. We analyzed the data with scan paths. We have looked at the heat maps or the heat map here in the aggregated form. And finally, we visualized the transitions over the areas of interest with a parallel scan path visualization and then with a bar graph visualization. If you want to know how these visualizations are working, please have a look into the previous video. In this video, we will go now one step further beyond scan paths, heat maps and a statistical analysis. We will use the power of the PC, of the computer, to find patterns for us. And this works very simple. I'm clicking on the area of interest editor and saying I want to do now a sequence analysis. So this is this component. I go a step back and we have a look at the area of interest map. So we defined 5 areas of interest for the top of the bar B, for the top of bar F, and the label B and the label F, and here the center, because we asked the participants to start their eye movements from the center of the screen. This sequence analysis now shows us common eye movement patterns which have been found in the data. In the moment we are searching for common eye movement patterns which could be found in all the participants, so in 100% of the participants. Here are the different areas of interest which we defined before, and here you can also find the area of interest not available, so where the eye tracker couldn't find the eyes. So I moved that to ignored, and also none I moved to ignored because I'm now only interested in transitions between the areas of interest which I've defined in the AOI editor. Also, I will move the center AOI also to the ignored column. And then I start to decrease the percentage of participants where a common eye movement pattern has to be found. So we are now at 100% and now comes the magic. Let's see what will happen. I reduce it to 90%. So 90% of the participants focused either on the top of bar F, on the label F or on the label B. So these are single AOIs, that's not a transition at this moment, but it gives us a first information. I'm reducing that now to 80%, to 70%, to 60%. And at 60%, we can see now that 60% of the participants performed the transition from top of bar F to top of bar B, or from the label F to top of bar F, from the label B to the label F. So there are now some eye movement patterns which have been performed by 60% of the participants. To better understand now who these participants are, I go to the parallel scan path visualization. And it's the same visualization which you've seen in the previous video without markings, now with the green markings showing this pattern which the sequence analysis has found. One of them. And to better understand now, to analyze now the eye movements, I'm using now the sequence search. And with the sequence search, I can define now a transition path over the areas of interest. Now we know that the software found the pattern from top F to top B. So I'm putting that together here manually now. Top F, top B with NA, none, or center in between. I deactivate the sequence search, and now I only see the pattern top F, top B. So this is now a common eye movement pattern performed by 60% of the participants. There are also some other areas of interest which have been focused on by the participants so that they are able to perform the given task. Because they had to state the labels as well. So not only compare the height of these two bars here, which is indicated by this pattern here in 60% of the cases, in 60% of the participants, they also have to read the labels. Otherwise, they are not able to answer the given question. So I'm going to the parallel scan path again, and then I'm opening another sequence search. And here I'm interested only in situations where the participants focused on label B. I'm using a different color, so I'm saying this should be, for example, blue. I'm going to the parallel scan path. These are now the moments during the experiment where the participants focused on label B. And I will do the same for label F. So I'm moving label F to here, and I will change the color, let's say somewhere like purple, close, go to parallel scan path, and here I can see now the label F's, B's, and what the sequence search found, top F, top B, in parallel. And now I can study the data because the question was, or still is, are there common eye movement patterns in the data? Yes, there are. First, we can find the sequence top F, top B, marked in yellow. We can see that this is distributed over the participants, and we can find the moments where the participants focused either before, like here, on the labels, or afterwards they have compared the heights, the values of the bars to read then the given values. And with these findings, we can go now into the statistical analysis. So I go to the sequence search, I open a simple statistics, and I visualize the results of the simple statistics with a diagram. I have to adjust here some parameters, select all the participants, aggregate them, and this diagram shows us now the number of the sequence top F to top B over the different participants. So we can see that 60% of these participants have performed this pattern at least for one time, and some of them performed this pattern twice, so for 2 times, and one of them for 4 times. I can export this data now together with all the other findings and can do a statistical analysis. And with that, we can understand how people are reading or are performing this given task, how they move their attention over the stimulus, and what the common eye movement patterns are. Thank you very much for watching this video. If you liked the video, if you learned something new, please press the like button, subscribe to our channel for watching other videos, and I'm looking forward to see you in the next video.